In this section, I want to talk about method references, which is actually a very simple syntax for what's a rather interesting idea. The idea is that a lambda expression is very much like a method, just it's a method without a name. It has parameters, it has a body, it could or optionally have a return value or not. A method reference is basically taking a method in a given class and converting that to a lambda. So we are referring to the method. In other words, some other languages like in C or C++, they'd refer to that as a function pointer or something similar. So in Java, we call them method references. And I have a simple table here that I want to show. This comes from the Java tutorial. If you simply Google the Java tutorial and method references or lambdas, this is an example. You can reference a static method by putting in the name of the class and then a couple of colons and then the method name. Or you can use an instance method on some object by using a reference and then the method name. You can do an instance method of an object of a particular type by using the class or interface and the method name. And you can even use new on a class as a way to refer to the constructor in that particular class. So let's take a look at some examples. So here I have my stream of, and I've created a stream, and I want to use for each, and before what I did is I used a lambda. In other words, to remind you what the lambda looked like in this, let me write it again. So instead of using the lambda here, I'm going to say for each number n, I want to print out n, like that. And this is the lambda expression because it takes the single argument, uses the arrow, and then it prints it. And of course, my IDE already desperately wants to convert this to the method reference. Here's what the method reference would look like. Go to system.out and then access its printline method in the resulting print stream object. System.out returns a reference of type printstream. Printline is a method in printstream, and I could use that as an argument to for each. Remember, the argument to for each has to be a reference of type consumer. And by choosing printline, I have selected an existing method that takes a single argument and returns void. That satisfies the contract for consumer. By using the method reference, I can say assign that method to the consumer interface. I also can set that up as a separate reference, just to be explicit about it. I could say I have a printer as a reference of type consumer of integer and use the method reference to essentially point to the printline method in printstream and then just use that in the argument as well. So it's very simple to use, and it's simply an interesting syntax that converts a method into a lambda, if you will. Now this can be used with any reference that you like. Now, as another example, not just of method references, but of using lambdas in streams, here is a traditional mechanism of getting a file, and I want to print out only the Java files within that particular directory. Now, in this case, I want to go down to lambdas and streams, the package that I happen to be in now. And I can print out the absolute path, and inside the file class there is a method called list that takes a file name filter as an argument. Now we'll revisit this when I talk about paths, just to discuss the alternative mechanism with paths and files. But the idea behind the list method is that it takes an instance of file name filter as an argument, and the file name filter interface has an accept method that takes two arguments, and you just return a Boolean to say whether a file should be included in the filter or not. So in this case, the accept method takes a file for the directory and a string for the name, and I'm returning name.ends with Java to say that only Java files will be included. Now list is going to return an array of type string, and I'm saying turn that into a stream from arrays.stream, and then invoke for each, and there's my method reference. So I'm going to print them out one by one. Now this is the complicated way of doing it because this is using the anonymous inner class. Here is the lambda expression approach instead. Notice that the signature of the lambda expression matches the signature of the accept method. Now the method names here, pardon me, the parameter names are arbitrary. I didn't have to call it dir and name, but there have to be two of them and they have to correspond to a file and a string, and then the body is exactly the body of my accept method. So that in this case, I have used a lambda expression to replace the anonymous inner class, and then once again just print everything out. Of course, if this looks a little complicated in the chain, I could always assign that to a variable of type file name filter, and then use that as an argument to list and print them out one more time here. So if I execute this, I should see all the Java files multiple times because I basically am doing the same print 3 times on each of them. So there's an example of using method references with print line and using lambdas assigned to an interface that's not one of those functional interfaces in the java.util.function package. The annotation functional interface that shows up on these is not actually required. It's simply a marker interface to tell anybody who happens to be using this that this is in fact a target for a lambda expression. If I went and looked at file name filter, which has been in Java since version 1, you'll see that also has been annotated with functional interface because it only has a single abstract method in it and therefore can be used as the assignment target for a lambda expression or a method reference. And there's the accept method. So we saw that whole process again working with lambdas and method references. Now I need to combine this with streams so that I can do things in a somewhat more interesting fashion. And that'll be the topic of the next section.